Hi there, welcome to this EHEDG Connects news update. Smart choice of you to tune in because we have something to share with you that is of real value to you. EHEDG is going to share the previously recorded EHEDG Connects webinar with Debra Smith. She's the Global Hygiene Specialist at EHEDG Company Member Vikan, and she is going to focus on those areas of the food processing environment that are often neglected, like cleaning tools. After the presentation, you will see a recording of the Q&A session, and if you want to be able to ask questions yourself to our EHEDG Connects hygienic design expert, make sure to subscribe and attend the next EHEDG Connects webinar. Thanks for now. We're looking forward to the presentation. Debra, the stage is yours, and for all the viewers, enjoy and learn.
So I'm sure that most of you here today are an educated audience and know that hygienic design relates to how easy it is to clean something. And that needs to consider both the hygienic design and the materials of construction. By considering those two things, the application of hygienic design minimises the risk of product contamination and results in better food safety and quality. Globally, again, I'm sure many of you are already aware, there are legal requirements related to the construction and the materials used for food processing equipment. These are the ones that are used in the EU. These are regulations and directives, and the US will have similar legislation. In relation to guidance, it's the European Hygienic Engineering Design Group, or EHEDG, that provide that guidance in Europe and in other parts of the world. In the US and in some other countries, it will be 3A that provide the guidance on hygienic design, but the two groups do work very closely together. Some guidance is also supplied by the National Sanitation Foundation, ISO and BSI. So it's not really surprising that GFSI are now starting to get in on the act. So who are GFSI? Again, I'm sure many of you are already aware, but they are the Global Food Safety Initiative, and they're a non-profit foundation that was created in 2000. They're managed by the Consumer Goods Forum, which is a business-driven initiative for the continuous improvement of food safety globally, and is operated by a consortium of people from very diverse aspects of the food industry, from food safety experts, food retail, food manufacturing, food service providers, and also international organisations, governments and academia. I'm sure that many of you will be familiar with the more popular GFSI food safety standards like SQF, BRC and FSSE 22000, but there are a growing number of others. However, currently, the only specific mention of hygienic design in these standards appears in BRCGS and in FSSE 22000. And these are related to cleaning equipment. So BRCGS says cleaning equipment shall be hygienically designed, and FSSE 22000 says tools and equipment shall be of hygienic design in relation to cleaning and sanitizing agents and tools. But there's no specific mention of hygienic design anywhere else. And if you're looking for it in relation to food processing equipment, you'll struggle. So this is an example of the current BRCGS standard for equipment, and although it does mention hygienic, it implies hygienic design, there is no specific mention of it. So it says all food processing equipment shall be suitable for intended purpose and shall be used to minimize the risk of product contamination. And that's strange because we know that the application of hygienic design has many benefits. I've already mentioned that when applied to food production, it leads to improved food safety and quality by minimizing the risk of food product contamination. It also means that it reduces the risk of product rejection and recall, both of which can be costly and damaging to the food producer. And because hygienically designed equipment is easier and quicker to clean, it can save time, money, energy, and chemicals. So to date, much of the information related to hygienic design has been focused on the food processing equipment, but there's now a realization that many other things within the food production environment can be a source of contamination. For example, the building itself. So things like the walls, the floors, the drains, the pipework and the doors, the utilities, the lighting, the air conditioning systems, refrigeration systems, personal hygiene facilities, bins, trolleys, control panels and workstations, and even the cleaning equipment itself. And studies of the food production environment have actually confirmed this. So this is a study that I'm sure many of you have seen before. I've presented it on many occasions, but it's a study conducted by Camden BRI for the UK government, where they sampled food factories, ready-to-eat chilled food factories, and they took 10,000 samples. And for the equipment that we normally focus on, the food production equipment, they found the incidence of listeria on that equipment to be very low. However, when they looked at things like floors, they came up with 17% positive results, drains 25%, and the cleaning equipment at 47%. So these are all examples of environmental sources of contamination not related to the food production equipment. Now, whether these findings were related to poor maintenance or poor hygienic design, we don't know. But here are some others. So the concrete floor surround in the drain in the top left-hand corner is badly cracked and now provides a place for dirty drain water and contamination to hide and be difficult to remove. Additionally, the type of drain shown is a slot drain, which is only about 5 centimetres wide and is extremely difficult to clean. So these are not good hygienic designs. It's been badly installed and badly maintained, all adding to the problem of contamination within the food production environment. The wall-to-floor junction in the top right has been poorly installed and now allows water and contamination to accumulate underneath and behind it. It's also difficult to access because of the guardrail that's in place, so getting to that area to clean it is made more difficult. And then if you look at the drain in the bottom left-hand corner, it's actually deliberately been welded shut, so now it's impossible to clean. So these are all good examples of where we can find hygienic design faults within the food factory environment other than the food production equipment. This door frame was found in a food plant that had experienced an issue with persistent listeria, and during refurbishment, the plastic door frame, the hygienic plastic door frame, had been removed to reveal rotten wood beneath, and that was the source of the contamination. High-speed roller doors have been commonly used in food production facilities, but there's now a concern that any contamination on the floor, particularly in a wet environment, can be aerosolized onto the product or drip onto the product as it passes below. And this recent study looking at freezer doors and door seals found that 8.5% of them were positive for listeria, so possibly not a good hygienic design there. Personal hygiene facilities can also be of poor hygienic design. I'm sure some of you recognise this form of hand dryer. The image on the left and the centre show the biofilm build-up in the high-speed air hand dryer. We've used a chemical spray to visualise this. And the microbial cells in those biofilms can be spread for metres by the air that's used in the hand dryers. You can even apply hygienic design to boots. So we know that the treads on boots need to prevent slips and trips, but it is also important to consider how difficult those treads are to clean. And as you can see, the boot on the left is much more difficult to clean than the one on the right. Electronics within food production facilities have always been a hygiene challenge, particularly where places are wet cleaned. In this image, the site operatives have realised that there's a need to seal the press button with a cover, but actually what they've done is made it worse because the cover that they used allows water to get in, and we've got now a microbial sludge that's developed underneath that switch. And where the water can get in, the microbes can get out every time that that button is used. The smooth sealed control panel shown below is obviously a much easier hygienic or better hygienic design and much easier to clean. Traditional keyboards are a real contamination trap, and they're often used in food production environments, but they are very difficult to clean. So if you're going to have these, then maybe try to choose these sealed keyboards like this one, which are much easier to clean. And hygienic Design can even help with control of COVID-19, very topical at the moment, obviously, because all of these frequently touched surfaces are COVID cleaning friendly, being much easier to frequently disinfect. Badly designed and site constructed cleaning tools and utensils can also be a major source and vector of contamination. In the top left, you can see a broom handle screw thread cover that has been designed in a way that makes that provides an ideal place for microbial biofilms to form, and in particular, cleaning up inside that green connector is virtually impossible. If you look at the bottom right, this tool storage rail system provides an ideal area for contamination to accumulate and be difficult to remove. This system was actually seen in a dry goods site where it led to pest infestation and the increased risk of cross-contamination from dry allergen debris. So when you take all of that into account, it's not really surprising that a few years ago now, GFSI decided to convene a technical working group on hygienic design to promote hygienic design more broadly within the food environment. They wanted to develop benchmarking requirements for their global food safety standards. Over the course of the working group that was put together, which included members of EHEDG, developed two new scopes, J1 and J2. J1 focuses on the requirements for facilities, constructors and equipment manufacturers and provides a new certification opportunity for these food industry suppliers. J2, just go back on that one. J2 focuses on the requirements for facility and equipment users, so people like ourselves, and builds on the existing GFSI benchmark requirements. Both scopes are organised in a similar way and are compatible to existing GFSI benchmarking scopes. Each consists of 3 sections. Section 1 is on HACCP requirements, Section 2 on food safety management requirements, and Section 3 on good industry practice requirements, all with a focus on good hygienic design. These scopes have been built around the following facilities equipment hygienic cycle, and we can start at the top, where we identify the intended use of the building or piece of equipment to be designed. This means that we're limiting the use of that building or piece of equipment to a specific purpose. That's a key aspect of this process. We then need to undertake a risk assessment against the specific purpose and the specific facility or equipment to identify the hazards associated with that piece of equipment or building that might be present, generated or transferred to the food by the product or to the product. Once these have been identified and risk rated, we're going to apply good hygienic design principles to try to mitigate any of the risks that we've identified. We then need to take in that hygienic design and construct the building or equipment hygienically so that we don't introduce any hazards to it. We also need to ensure that we don't introduce these hazards while building or installing or commissioning the building or equipment. We then need to consider any remaining hazards, and there will always be some remaining hazards, particularly in machinery that moves. That's because there's a need for equipment where there's moving parts to guard them from a health and safety point of view, but at the same time we need to make sure that the guard is something that can be removed to allow good cleaning too. Ongoing mitigation of hazards is usually achieved through good maintenance, including cleaning. And finally, we have the management of change, where we periodically reassess whether the building or equipment is still fit for purpose. Now, one of the key recommendations made by the Hygienic Design Working Group was the need to assemble a multi-disciplinary team, similar to those that we use when we're doing HACCP. And this team then worked through that hygienic cycle. And there was a realization, and no offense to any of the engineers online because you're all excellent guys, but that the task had often been left entirely to engineers who may not have had all of the relevant safety knowledge or experience that was required to achieve a fully effective outcome. And so many other experts really need to be included. In addition to this, providing the relevant knowledge will be another key component of these benchmark requirements, including awareness of the legal and industry standard requirements and a good understanding of hygienic design principles. Therefore, the 3A and EHEDG standards and guidelines will play a key role in providing this knowledge and in defining hygienic design requirements for future GFSI recognised food safety standards. Also for standards auditors, the food and equipment and facilities manufacturers. So all of those people will be looking to organisations like EHEDG and 3A for that information and guidance. There are some relevant EHEDG guidelines, and here they are. I'm sure there are many others available through 3A and NSF, but these are the ones that we can point in the direction for European hygienic design. I'm also sure that the existing guidance and training will require some revision, and that new material may also need to be developed. So if you have any hygienic design expertise, and I'm sure many of you do out there, you may be in demand. So what are the key hygienic design principles that we should be aware of? We need to develop equipment that have no sharp internal angles, have smooth surface finishes, where all areas are accessible for easy cleaning and disinfection, ideally with no nooks and crannies, possibly of one-piece construction, if not of one-piece construction, easy and quick to disassemble and reassemble. They should minimise the risk of foreign body hazards, and they should be made of food contact compliant materials. So let's take a look at each of these in more detail, using cleaning equipment and utensils as examples. So we'll start with no sharp internal angles. And on the left, you have an example of a squeegee where the way it's moulded results in an area with what we call a sharp internal angle. And as you can see illustrated by the EHEDG diagram below, sharp internal angles are areas where contamination can get trapped and be very difficult to remove. To avoid the contamination trap, internal corners and angles should be soft and rounded, and ideally the equipment surface should be sloped away from the corner to allow for drainage. Application of these principles can be seen in this red squeegee. So how about smooth surface finish? Well, this brush was made of foamed plastic. It is a brush that's supplied to the food industry in the US, but unfortunately that foamed plastic gives it a very poor surface finish. And what we've done, we used a UV sensitive gel, which is often used to demonstrate hand hygiene compliance, to show how the contamination, the gel, gets trapped in the surface defect and remains there even after washing. Now, there is a recommendation from EHEDG on surface roughness. It's known as RA, and it's recommended that an RA of less than 0.8 microns is cleanable. That's for stainless steel, not for plastic, but it gives you a ballpark figure to work to. Okay, easy to clean. It's, as a brush manufacturer, it is extremely difficult to make a good brush of good hygienic design. When you think about the way that a brush is constructed, traditionally, you take a block of plastic or wood, you drill it full of holes, and then you staple in some bristles, all completely opposite to good hygienic design practices. So the construction of the brush that you can see here, again using that UV gel, shows where excess plastic around each hole has got trapped. Has trapped the contamination, and if you look at this one, which is a traditional drilled and staple brush that's been cut through, you can see the UV gel where it's got trapped deep down inside the drilled hole and actually would be virtually impossible to remove. Okay, easy to disassemble. I had to smile when I saw this image on the instructions for a squeegee that we found. The instructions require the use of a screwdriver to lever out the blades for a replacement. And that really means that either you have to take the squeegee to the workshop where the screwdriver is, or bring a screwdriver into the production area. And obviously both actions increase the risk of cross-contamination, but they also discourage blade changing because of the extra effort involved. We know psychologically that people need things to be easy to do, otherwise it won't get done. So all of these things point to a bad hygienic design. The squeegee on the right has a mechanism that allows for quick and easy manual removal of the blade for cleaning or replacement. Now let's turn to materials of construction. One of the main issues that we've encountered with food industry cleaning tools and utensils is the lack of awareness that in those products that are in contact with food or food contact surfaces, by law, must be made of food contact compliant materials. Different regulations apply in different parts of the world again. These are the ones for Europe and in the US, but they're also applied in other parts of the world. But you should always check your local regulations and which ones apply to you. All the regulations are similar in respect that they must be made of food contact materials that are durable, heat resistant and chemical resistant. They should be non-absorbent, and most importantly, they should not transfer harmful substances to the food. Now, in Europe, that last requirement for plastic tools and utensils is assessed in an accredited laboratory, so a physical test is conducted. And what they do is they take the tool material, the plastic material, they place it into a number of food simulants, including things like oil and acid and water, whichever is appropriate, and they leave it in that food substance for a set period of time at a set temperature. And then after that time and temperature, they analyse the fluid to see what level of components have transferred into the liquid. And if they are below the acceptable levels, then the material is compliant. Then, by European law, the results of the tests must be used by the tool manufacturer to produce a declaration of compliance, or a DOC. Now that should be available to the customer of the tool so that they can check the suitability of that tool for the intended purpose. And all Vikan products have DOCs available for download from our website and can be used to demonstrate food safety compliance during an audit. Here's an example of a DOC, but don't think just because a DOC is available that the equipment is suitable for purpose. By European law, the DOC should also tell you which foods and which temperatures the equipment is suitable for use with and how long the tool can be used. And it will also tell you if there are any restrictions for use. So this DOC is for a brush that uses resin to secure the bristles and states that the resin that's used is not approved for direct food contact. So this brush is perfectly good for sweeping of non-food contact surfaces or direct contact with food, but not anything which will then subsequently come into contact with food. Unfortunately, not all food contact cleaning tool utensils and manufacturers are aware of the regulations or are fully compliant with the law. So make sure you ask them for evidence of food contact compliance and check the documentation carefully. At Vikan, we are continually incorporating hygienic design principles into our new and improved products, especially regarding food contact compliance and one-piece and fully moulded construction. One of the biggest advances in cleaning tool hygienic design has come with the development of our ultra-safe technology range. UST technology brushes are constructed in a completely different way to traditional brushware. They're fully moulded, they don't have any drilled holes, they have no metal staples, no resin or glue to secure the bristles. This means that contamination is much less likely to become trapped and is easier to remove. And the risk of bristle loss is also significantly reduced, therefore reducing the overall foreign body risk. Unlike traditional brushware, where one bristle from the bundle is lost and then the others become looser and more likely to fall out, each bristle in a UST brush is individually fixed to the block, meaning that the loss of one bristle doesn't affect the security of the others. UST brushware is also made entirely of food contact compliant materials and conforms to many hygienic design principles. And as a Danish-based company, I will take the opportunity to steal a famous Danish beer tagline, and say that although not perfect, the UST brushware is probably the most hygienically designed brushware on the market today. The reason we focus on developing hygienically designed cleaning tools and utensils is because we have found many examples of poor hygienic design in the food industry, and these include the use of screws as fastenings, the use of toxic plastics and colourings, poor quality bristles, and inappropriate materials of construction, including things like wood, fiberglass, painted or coated items. We've also visited many sites where we found equipment that's been made on site, which is also poor hygienic design. So this brush has been made by bolting a Vikan pipe brush onto the head of a wooden handle using a metal fixture. These scraper blades, the heads have been taped to various handles, obviously not very hygienic and certainly not audit compliant. And the wire brush here uses iron, rubber and wood in its construction. So all of these will increase the risk of product safety and quality. However, we really do quite like to find these because it actually drives our new and improved product development process. So based on the site-made scrapers that we've found, we actually developed or we realised that there was an industry need for scrapers with longer handles, and we developed a range that could be fitted to any length of Vikan handle to allow scraping in many different areas. Of course, incorporating hygienic design principles into everything we use in a food factory will have implications for the food industry. The new GFSI benchmarks will require greater focus on hygienic design during GFSI audits. There will be a need to have this multidisciplinary team, which you may not currently have. So you might need to draft in people or commission people to come and help out. There will be a requirement to review and apply food safety risk assessments related to hygienic design, both new and in legacy buildings and equipment, from farm to fork. So it's a very wide scope. And some things just may not come up to scratch and will need to be upgraded and replaced. There will also be a need to provide training related to hygienic design to all involved. So, like all change, I'm sure there will be fear of the unknown and initial resistance to the scopes. Consequently, don't panic, both scopes are currently voluntary. However, GFSI and the hygienic design community truly believe that the formalisation of what many companies already do to a greater or lesser extent will drive future food safety and ultimately lower costs and provide a more efficient food production platform. So we would really encourage the food industry to support these scopes and to encourage CPOs to adopt them. In the meantime, I'm going to leave you with 3 top tips on hygienic design. First, choose equipment that is compliant with the regulatory standard or guidance requirements and consider good hygienic design and materials of construction. Consider all possible sources and vectors of contamination, including the building itself, personnel equipment, electronics and cleaning equipment. And seek advice from the experts. So EHEDG are here, 3A are here, and so are the manufacturers of hygienically designed equipment and facilities. And what we want you to do is reach out to us and we can support you. Many thanks for your attention, and if you'd like any further information about EHEDG or the GFSI, please check out the links that I've provided here, and thanks again.
Thanks, Debra, for this very insightful presentation on hygienic design and the cleaning tools. And yes, our audience has been submitting a few questions already. Okay. May I just start with the first one?
Please do, yes.
Really related to your last couple of slides. How can food manufacturers ensure that they use food safety compliant equipment and facilities?
Great, I'm really glad that someone's asked that question, because that's one of the things we're trying to get across in this webinar. So really the first thing to do is to find out what the regulations and standards are. So go to whichever standards you work to, go to them, read through them carefully, and pick out anything that talks about design of the equipment for cleanability. As I say, you won't find many mentions of hygienic design per se, but look for those keywords about design and cleanability. Then go to people like EHEDG and 3A and the other experts and ask their advice on how to meet those standards and requirements. There's so much information and support out there. And say one of the reasons we were running this webinar is to try to get that information out to a broader audience.
Thanks. Very connected to it. How can we raise awareness of these hygienic design principles and requirements to all stakeholders, to all concerned people?
Again, things like this webinar, fantastic. You know, we can hopefully reach out to some people that we haven't met before. I know a lot of the audience are already committed EHEDGites, very committed to hygienic design, but if we can just catch a few people each time and spread the word by doing these kind of events, then that's one way. Word of mouth is another. You know, if you have a good experience in your factory where you've tried a hygienic design solution and you've actually found that it's improved your efficiency or reduced your costs, sharing stories like that with us so that we can share them with the members and anyone else. Maybe even just putting a short story on LinkedIn would be great. One of my key ambitions is we always focus a lot of our stuff on engineers, and actually I'd like to focus it on purchasers, because the purchasers are often the ones who make a decision on what's bought, and they often base it on cost. And hygienic design comes with a cost, but ultimately the cost is reduced because of the efficiency and increased production. So it's trying to get that message across to purchasers initially that I also think is an important message.
Great, thanks. And why should the COPs adopt the new GFSI hygiene design benchmark requirements?
That's a really good question. I can understand why COPs might not want to, because it's a lot of additional work. But I think, fortunately, we're very lucky that many of the certification operators their main focus is on food safety. And I see this as the next step in developing a robust food safety program. There is some recognition already about hygienic design within the current standards. This is just the next logical step. And I think a lot of people might think, well, do we really need to tell people that they need to design things and use things that are cleanable? I think if you asked that question about food safety culture a couple of years ago, you know, do we have to tell people that they have to be responsible? Well, obviously we do, because we've now incorporated that into the GFSI standards. So let's do it with hygienic design as well.
Thanks. We might have a last question about J1, the scope of J1. Is it a correct interpretation saying that the scope of J1 is a certification for engineering contractors?
It can be used for that. It offers two parts. So J1 does offer a new certification opportunity for equipment manufacturers, and I think that's something that will be developed further within EHEDG. So if you'd like more information about that as an equipment manufacturer, then I think the best thing to do is get in touch with EHEDG HQ.
Thanks. Do we have a few other questions? No, that was the last one. So I think I can thank you once more for the insightful presentation, and I can give the word back to Rob. Thank you very much, Deb.
Bye.
Thank you, Debra Smith, for this very interesting presentation. Thank you, Christina Anoni, for moderating the Q&A session. Now, dear viewers, if you are an hygienic design expert yourself and you feel comfortable conducting one of these EHEDG Connects webinars, please get in touch with the EHEDG office via the email address down there, because we are in the process of planning the future EHEDG Connects webinars. And we want to shed a light on hygienic design from different expertise areas, from different perspectives. So very welcome to participate. Thanks for now and see you at the next webinar.